Okay, and here's today's lesson. Our one objective, we will be able to use the law of cosines to solve any triangles. We are in section 7.3 in our textbook. We need the law of cosines when the law of sines will not be able to be used. There are two cases where that will happen: side angle side and side side side. Remember, to use the law of sines, we need an angle and its opposite side. Clearly, I'm not given any angles with side side side, and the angle that I am given with side angle side, we would not have the opposite side. So I cannot use law of sines to begin these two problems. I need law of cosines. The law of cosines states that if A, B, and C are the three sides of a triangle that are opposite their corresponding angles, A, B, and C, then we have three laws of cosine. We have A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. Wow, pretty long and involved there. But you'll start to see the pattern when I give you the other two. This I would consider to be the A law of cosine because it's either going to help you find side A or it's going to help you find angle A. The B law of cosine would be B squared equals A squared plus C squared minus 2 times A times C times the cosine of big B. And seeing that, you might start to see the pattern for these laws of cosine. You might be able to recreate the C law of cosine following this pattern. C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of big C. These are the three laws of cosines, and they might look similar. What might be ringing a bell? Pythagorean theorem. Looks like Pythagorean theorem. In fact, this third one looks identical to the Pythagorean theorem. C squared equals A squared plus B squared. It just has this extra term here. Well, if you remember, Pythagorean theorem, of course, only works for right triangles. And in a right triangle, angle C would be 90 degrees. And the unit circle says that the cosine of 90 degrees would be 0. So this term would actually erase itself and become 0, leaving exactly the Pythagorean theorem. So yes, these are derived from Pythagorean theorem, and this extra term here is just the little adjustment that's needed for when the angle is not exactly 90 degrees. So let's look at our first example. I've given you some pieces. I always have to give you the three pieces of information. Angle A is 52 degrees. Side B is 6, and we know that side B is opposite angle B, so there's my 6. Side C is 8, and I know that side side C is opposite angle C, so there's my 8. The side that's missing is A, because that's opposite the angle A. I cannot use law of sines yet, because the only angle that I'm given is opposite this side, and that's the only side that I don't know. I cannot use Pythagorean theorem because I don't know if this triangle is a right triangle or not. Since I don't know that, I have to assume that it's not. And so this is why I need law of cosines. I'm going to do law of cosines here, and I'm going to do the A law of cosines, the one that says that A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. The more times you write it down, the more times it'll get into your memory. A squared, well, I don't know what A is, but I do know what B is. B is 6, so this becomes 6 squared. C is 8, so that becomes 8 squared. Minus 2 times the 6 and the 8 again, and this times the cosine of 52 degrees, which is angle A that I'm given. So this can all be dumped in the calculator, and we can take the square root and we'll have what A is. I'm going to do a little bit more by hand just to show you something that you cannot do. 6 squared, of course, is 36. 8 squared is 64. 2 times 6 is 12. 12 times 8 is 96. So this is negative 96 cosine of 52 degrees. 36 and 64 make 100. Minus 96 cosine of 52 degrees. I want to stop here and mention something right here. These are not like terms. You cannot take the 100 and the 96 and subtract them in any way, because this is a coefficient to our cosine of 52 degrees. So please don't do something like that. Okay, so we need to solve for a, and I'm going to take the square root of both sides so that a squared turns into a, and I'm going to have approximately whatever this says from our calculator. So let's get our calculator out. And I have the square root. In my calculator, I have the better operating system that has the square root and the cursor is right underneath there. If you have the older one, then you have a parenthesis. Just please make sure you close the parenthesis. I have 100 minus 96, and then the cosine, which opens up a parenthesis, and I will close that parenthesis. Let's press enter, and I have my side 6.395. 6.395. Now I know that I'm going to need this number for later calculations, so I'm going to be using my store button yet again. So let's get our calculator. This is the number that I want. I don't want to use a rounded number. I want to use this exact number. So I'm going to push the store button, which is above the on, and it's going to store the previous answer in for whatever letter I want. And since this is angle A, or excuse me, side A, I'm going to choose A from my calculator. Press enter, and now A will always represent that number until I reset the calculator or I change the value. So that's good to know. So now that we have angle A and side A, we can use the A ratio and now go to law of sines. So I'm going to do that. Let's go to different color. I know that 6.395, I use a little dot, dot, dot. That's just a symbol for me to know that I'm using an exact answer, something that's stored in my calculator. The side divided by the sine of its angle, 52 degrees, will be equal to, I can do either the B ratio or the C ratio. I will just go in alphabetical order. Side 6 divided by the sine of its angle, and there's my proportion. I'm going to cross multiply, and I will start here. 6.395 times the sine of B is equal to 6 times the sine of 52 degrees. Trying to find B, so I'm going to get rid of this number, this 6.395. Oops, I forgot a little dot, dot, dot. Again, that's just a symbol for me. And I have the sine of angle B is equal to this 6 sine of 52 degrees divided by 6.395. Angle B, or the measure of angle B, is going to be equal to the inverse sine of that big fraction. So the measure of angle B is going to be approximately, now I'm going to type this into the calculator. So let's get the calc back out. I've got the inverse sine, so inverse sine, and I'm plugging this whole thing in there. I've got 6 times the sine of 52 degrees. Be sure to close that parenthesis before you divide by. Now I'm going to be using the exact number, so I need to push alpha A. Close the parenthesis for the inverse sine, and we will have our angle. 47.675. The 4 has to go up because the 6 is going to force that up. We have to round correctly. 47.675 degrees. Most of the work is now finished because we're just missing one angle, and we know that all 3 angles add up to 180 degrees. So measure of angle C is really not going to be that difficult. We'll take 180 degrees, we'll subtract the 52 degree angle that we were given, and we'll subtract the 47.675 degree angle that we just found. That's not going to be too difficult to do. Measure of angle C, where's my calculator? There it is. Measure of angle C will be 180, take away 52, take away the previous answer. I'm going to call up the previous answer. I always like to do that. Previous answer is above the negative button. And so there I go. I'll press enter and I get 80.325. 80.325 degrees. Do not forget your degree symbols. And there's our first example. Let's look at our final problem. This time I've given you all three side lengths of a triangle. Side A is 21, so opposite angle A is 21. Side B is 16, opposite angle B is 16. And the missing side C over here is 10. So the first question I have is, how do you know that this even makes a triangle? Because just because I give you three side lengths doesn't necessarily mean that I've given you a triangle. If I give you the side lengths 1, 2, and 3, would that make a triangle? You have to recall from geometry that in order to have a triangle given three side lengths, the two smaller side lengths have to add up to be bigger than the third. This would not create a triangle. I know that this example is a triangle because of these three, the two smaller ones would be 10 and 16, and since they add up to 26, 26 is bigger than the other side, so we must have a triangle. But watch out for that. You always have to test the two smaller sides, add them up, and make sure that they are bigger than the third. Okay, we need to find all three of the missing angles. And really, we can go in whatever order we want. I'm going to go in alphabetical order, so I'll start with A. I know that A squared is equal to, let's slide this over a little bit. I know that A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of big A. There's our A law of cosines again. This time I know the side length is 21, so that squared would equal 16 squared plus 10 squared minus 2 times the 16 times the 10 again times the cosine of angle A. This time this is the unknown, this angle. I need to peel away all these other numbers away from this in order to solve for A. And the inverse cosine is the last thing I'm going to do. So let's do a little bit of this stuff by hand. 21 squared is 441. 16 squared is 256 plus 100 minus, this is 160 times 2, which would be 320 cosine of big A. Let's go ahead and subtract the 256 and subtract the 100 since these are separate terms. I'll do that from both sides. When I subtract this, I get 85, and that will be equal to negative 320 cosine of A. Let's divide the negative 320. And I'm going to use my symmetric property if you don't mind. I'm going to have the cosine of A come first. And this is equal to 85 divided by negative 320 reduces to 17 over 85. Not that you have to reduce it. The calculator will deal with either one of these fractions. That's fine. And of course I'm incorrect. That is not 17 over 85. It is 17 over 64. Makes a little bit more sense. So now we're down to this. The last thing we need to do is do inverse cosine. Measure of angle A is going to be the inverse cosine of this negative 17/64. So plugging that into the calculator will have the value for angle A. Angle A should be 105.404 degrees. 105.404, and don't forget your degree symbol. All that work to find angle A. The good news is we should not have to do law of cosines again. You could do that all three times if you really want to. Once you have one of the angles though, now we have the law of sines A ratio, and I prefer to use law of sines because I feel like it's a little bit faster. So now I'm going to do law of sines to go find one of the other angles. 21 divided by the sine of that angle, 105.404. I'm putting a little dot, dot, dot. Perhaps you store this into your calculator because we're going to be using that number again. So you can store that in for A. That ratio is equal to, oh, let's just go to the B's. We'll go to 16 divided by the sine of B. I'll go alphabetical order once again. Cross multiply, and we have 21 times the sine of B is equal to 16 times the sine of 105.404 degrees. Let's divide by 21 and get the sine of B all by itself, and we have that equal to this. And our last step is to take the inverse sine so we can have measure of angle B. Measure of angle B is going to be equal to the inverse sine of this big fraction that I don't really want to write again. So I'll just draw a little arrow. Inverse sine of all of this stuff, recalling this stored value, this exact value. For the measure of angle B, you should get 47.268. 47.268 degrees. I really hope that you take advantage of the fact that these three angles will add up to 180 degrees when you find the third one. In this case, we're missing angle C. I'm just going to do 180 degrees, and I'm going to be taking away the 105.404 that we did that may or may not be stored in your calculator. That would be good. Minus the 47.268 that we just found, and we'll get the final angle, measure of angle C, is 27.328 degrees. So that's the other type of law of cosine problems. Thanks for watching this tutorial. We'll see you in class, and we will practice this, especially the store button if you need help with that. Okay. See ya.